In lesson 5, we're looking at composite functions. There's really two parts to this lesson. The first is really understanding what a composite function is and how we can work with them, and then the second is graphing them. So we're going to be looking at all of that today. So a composite function is another way we can combine functions, except instead of our typical combinations like adding, subtracting, multiplying, and dividing, what we're actually doing is combining the functions by making one output a function of the other. So what does all that mean? Before we start looking at that, let's do a little bit of a recall of function notation as we worked with it in grade 10. So recall, if I tell you that f of x equals 2x minus 1, and I ask you to find f of 3, all you're doing is taking the 3 and substituting it in for the x. So if we rewrote this, it would be f of 3 equals, so anywhere in the equation that we have an x, we're changing it to 3. 2 times 3 minus 1. 6 minus 1 equals 5. So what this is really telling me at this point is that when x equals 3, y equals 5. Because remember, f of x is just the function notation version of y. So the notation that we use for a composition is f of g of x. So the main thing to note here is that it's really different than multiplication because it's an open circle. So it can often get confusing. Is it multiplication or is it composition? So if you see an open circle, just remember it's composition. The other way we can write it, which I prefer so that that open circle doesn't get confused with multiplication, is we can write f bracket g bracket x and then close the brackets. What this means is you're always doing your inner brackets first. So you kind of think of it as like a BEDMAS situation where you do the brackets first, and then whatever answer you get for what's inside the brackets, in this case is g of x, you're then going to substitute to your outer variable, which is f of x. We read this as f composed with g of x or f of g of x. You'll typically hear me use this notation here. All right, so let's start with the different ways you can be given data. So the first is we can be given tables and asked to do composition with the tables. We have two tables here. We want to use these tables to answer the following questions. So note that the first table represents f of x, the second table represents g of x. So if we look at A, f of g of negative 1, the first thing we're going to do is we're going to solve g of negative 1. So we haven't done anything with the f right now, so we're going to leave that. And then in the bracket, we're going to replace g of negative 1 with the answer. Now remember what g of negative 1 means. G of negative 1 means to look at your g of x table of values and find where x is negative 1. So if I go to my table of values and I find where x is negative 1, I can see that g of x, or y at that point, is 2. So g of negative 1 equals 2. So all I'm doing is substituting that in. I've now completed my inner function. Now I'm not done because now I have to find f of 2. What is f of 2 asking me to do? F of 2 is asking me to go to my f of x table of values. Again, the 2 is an x value, so find on the table of values where x is 2, and the answer is the corresponding y value. So f of g of negative 1 equals 0. All right, let's try B. Let's see if we can go a little bit faster. We're going to start with the inner function. So the g is staying the same. F of 1, go to your f of x, find where x is 1, and take the matching y value, which is negative 1. Now we're going to go to our g of x table of values, and on that table of values, we're looking for an x value of negative 1, and that gives us a y value of 2, and that's our final answer. All right, let's try the next two. Sometimes our inner and outer functions are working off the same function. So you'll notice in C and D that C just has f and D just has g. So we're just working with the same table of values twice. We're still going to work from the inside out. So that outer f I haven't changed, but I'm going to go to my f of x table of values. I'm going to find where x is 1, and I'm going to substitute that with negative 1. Now I'm staying with the same table of values, but now I'm looking for an x value of negative 1 to get my corresponding y value of 3. Okay? So at this point, pause the video, take a second, and try D. G of negative 1 means we're looking at our g of x graph. This is going to now change the question to g of 2 because we've solved our inner function. We're staying on the same table of values, but now we're looking for a different x value, and we end up with an answer of negative 1. All right, so we can do all of the same things now here, but using a graph. So same rules apply, just we're finding the right graph. We're using the x value that's given to find the matching y. So g of -1. So our graphs, unfortunately, aren't labeled. So if you want to take a second, the parabola is your g of x and the linear is your f of x. So you want to add those labels in. So g of -1 means we're going to where x is -1. So I'm going to do this just in a different color. So I'm going to use green. I'm going to go to where x is -1, and I'm going to line it up where my g of graph is, which in this case happens to be right on the intercept. So the y value of that point is 0. So this becomes f of 0. Now I'm going to go to where x is 0, and I'm going to line that up with my f of x graph, and that y value is 5. Okay. All right. I'll erase that. Let's try another one. G of f of 3. Start with f of 3. Go to where x is 3 and line that up with your f graph. What is that matching y value? It's 2. So this becomes g of 2. Now we're going to go to where x is 2. Now we want to line it up with our g graph. And that y value is 3. So g of f of 3 equals 3. Okay. Let's try the last one. F of 4. So again, we're starting with f of 4. We're going to where x is 4. We're lining it up with the f of x graph, which is linear. And we're getting a y value of 1. F of 1 now means stick with your same linear function, but now you're going to where x is 1. You're lining it up with the graph, and that y value now is 4. So the whole composite function equals 4. All right, now let's start working a little bit with equations. If f of x equals 4 of x, g of x equals x plus 6, and h of x equals x squared, determine. So we're going to start with the inner function. Okay, so for our inner function, we're using g of x, which means that in this function here, all we're doing is changing all of our x values to 3. So g of 3 is 3 plus 6, which means g of 3 is 9. So now I'm going to rewrite the original question, but instead of f of g of 3, I now know the answer for g of 3 is 9, so I'm just going to change it to f of 9. Now I'm going to be using the f of x function, which is in purple here. So f of 9 just means in f of x equals 4x, you're going to change it to 4 times 9, and you're going to get an answer of 36. Okay. All right, let's look at b. For b, we're starting with h of -2. So take your h of x equation. H of -2 is -2 squared. Make sure the -2 is in a bracket. This gives us a positive answer of 4. So we're going to rewrite the question. Instead of g of h of -2, we now have g of 4 because we've simplified h of -2. We're going to go to our g of x equation, which is x plus 6. We're going to change x to 4. And that's going to give us an answer of 10. So take a second to pause the video and try C. We're going to start with h of 2. So the equation we're using here is, once again, h of x equals x squared. So we have 2 squared, which means h of 2 equals 4. We're going to rewrite the question. Instead of h of 2, we have h of 4. And we're actually just plugging it back into the same equation, which is x squared. So 4 squared, which is 16. All right, so we've now evaluated using compositions. What we're going to do now is we're going to actually find the new functions. So let's take a quick peek at example 4. If f of x equals x cubed plus 1 and g of x equals 2 of x, determine f of g of x. So again, the order of this is going to be important because f of g of x is different than g of f of x. So don't think of it like how you think of multiplication because it looks similar, because in multiplication the order isn't necessarily that important. But here it is because it's going to determine your inner function versus your outer function. So I personally prefer to see it written like this because it tells me that my inner function is g of x. So that means if I take f of g of x, I'm going to start by plugging in my inner function. So wherever I have a g of x, I am plugging in 2x. The whole thing. So this will become f of 2 of x. Now I'm going to go to my f of x function, and everywhere I have an x, I'm going to plug in 2x. So instead of x cubed, it's 2x cubed plus 1. Okay, now make sure the 2x is in brackets because when you simplify this, you want the power of 3 to apply to both. So this is 8x cubed plus 1. Okay, and that's your answer. So note the steps on the side. Okay, write the expression for the function of g of 2 of x in the g of x spot in the composition. That was the very first step I did. Now substitute that into the f function in the x spot and then simplify if necessary. So let's try a few more examples with some different functions. All right, so we have f of x equals 5x, which is linear. G of x is quadratic. So let's start with f of g of x. And the first thing that I'm going to note here is that all I'm going to do in my first step is rewrite this by changing the gx to that x squared plus 1. Okay, now what I'm going to do, change my highlighter here. I'm going to use my f function, and everywhere that I have an x, I have to change that to x squared plus 1. Okay, now you're just going to simplify by multiplying to get rid of the brackets. All right, b is just changing the order of the inner and outer function. So at this point, I'm going to get you to pause the video, try this on your own, and then we'll replay it to see how you did. So here, your inner function is f of x. So you are going to be taking f of x, which is 5x, and substituting it in. So the g stays the same, but the bracket just becomes 5x. Now, I'm going to take g of x, which is x squared plus 1, and everywhere I have an x, it's going to be a 5x. So 5x squared plus 1. Make sure it's in the bracket, because if you don't put it in the bracket, your final answer would just be 5x squared plus 1, but it really should be 25x squared plus 1. Okay, so notice that f of g of x and g of f of x do not necessarily have the same answer. So it is important that you're doing it in the correct order. Okay, all right, let's try a few more. Okay, I'll do the first one with you, then I'll get you to pause the video and try B and C on your own. So same idea here for the first one. All we're doing is plugging in g of x. So this is going to become f x squared minus x plus 3. And then we're going to go to our f function. So instead of 4x, it's going to be 4 times x squared minus x plus 3. And that's done. So pause the video now, try B and C, and then we'll check back in and see how you did. For B, you're leaving g the same, and you're plugging f of x in. So it becomes g of 4x. Then you're taking your g of x function, and everywhere you have an x, you're putting in the 4x. So this is going to equal, instead of x squared, 4x squared minus 4x plus 3. And then you're just simplifying. For C, you're starting with your inner function of f of x, which is 4x, so this becomes f of 4x. Okay, and then you're using the same function, but now everywhere you see an x, you're putting in 4x. So instead of 4x, it's 4 times 4x, which is 16x. All right, so the last part of this lesson is going to be graphing. Now, just like when we graphed our other combinations, addition, subtraction, multiplication, and even our division, we really needed to think about how our domain was affected by combining the functions. So the same thing applies here. So the first thing that we're going to do is we're going to write our new function. So we want to determine f of g of x and g of f of x. Notice that on all the functions we've used up to now, they were linear and quadratic. We did have one in example 4 that was cubic. All of those functions have a domain of x as an element of the reals. So when we combine functions that have a domain of x as an element of the reals, it's not going to change the domain on the function when we combine it. So we don't have to worry about that. But in this case, the one thing we need to think about is this f of x. So if you think about what this looks like, this is our radical. So it's going to look like this. So f of x has a domain of x is greater than or equal to 0. G of x, x squared plus 2, well, that's just a parabola. So that has a domain of x as an element of the reals. So the one thing that we need to remember is that we always do the inner function before we do the outer function. So our composition is going to be restricted based on the restrictions of the inner function. So if we want to start with f of g of x, so this is just like we did on the previous page. Okay, g of x is x squared plus 2. So this is just going to become f of x squared plus 2. And then in f of x, which is the square root of x, anywhere we see an x, we're going to change it to 2. Okay. Now in this case, our inner function was g of x, which had a domain of x as an element of the reals. So our answer is also going to have a domain of x as an element of the reals. If we do it in the opposite order, okay, the first thing we're doing is changing f of x to the square root of x. And now in g, everywhere we have an x, we're changing it to x squared. So instead of x squared plus 2, it's the square root of x squared plus 2, which just simplifies to x plus 2. So notice that this ends up being linear. However, the restriction on this is not the same as a linear restriction, because remember that our inner function had a restriction of x is greater than or equal to 0. So that is going to actually have to be the restriction on our answer. Okay, so let's just make a note. The inside domain affects the new domain. So if you're finding the domain of f of g of x, you need to consider the restrictions on the domain of g of x, since that's your inner function. But if you're finding the restrictions on f of, so you always have to consider the restrictions on your inner function. All right, let's look at another example. Notice we're starting to bring in some reciprocals. So here's what we need to think about. We need to think a little bit about the non-permissible values. So in f of x, we would have a vertical asymptote at x equals -3. So that would mean that our domain is x cannot equal -3. And here our domain is x cannot equal 0. Okay. So now let's start with f of g of x. All right, so we're going to start by recognizing, and I'm just going to start writing a little bit less here. G of x is 1 over x. So I'm just going to plug it in here. Then we're going to go to our f, and wherever we have an x, which is just in the bottom here, I'm going to change that to 1 over x. So I end up with 1 over x plus 3. Okay? Now, let's think of this as 3 over 1. Because this is not simplified, we would need to find a common denominator, which would be x. So this ends up equaling 1 over 1 plus 3x over x. Now this is a complex fraction, a fraction within a fraction. We can't leave our answer like this. So what we're going to need to do at this point is we're going to need to like flip and multiply, just like we did with our trig identities. So the x is going to move to the top and the 1 plus 3x is on the bottom. So this is our answer. Now, however, we need to consider the restrictions. So keep in mind that the inner function had a restriction of x cannot equal 0. However, what I want you to notice is that once we've simplified f of g of x, we've introduced a new restriction because our denominator is 1 plus 3x. So if we find the non-permissible value now, we're introducing a new non-permissible value. So x can also not equal negative 1/3. That's just found by finding the new non-permissible value based on your new function. So f of g of x equals x over 1 plus 3x, where x cannot equal 0, and x cannot equal negative 1/3. Okay, let's try g of f of x. So g of f of x, again, I'm just going to do a little bit more simplifying in my head here. I know that f of x is 1 over x plus 3. So now what I'm doing is I'm taking g of x, which is 1 over x, and instead of 1 over x, it's 1 over x plus 3. Same idea as the last one, where I need to get rid of the complex fraction. So you're going to flip and multiply, and you end up with x plus 3. Now note your inner function of 1 over x plus 3 that we started with, f of x, has a restriction of x cannot equal negative 3. So we need to apply that to our answer. So even though this is a straight line, it will have a hole at negative 3, or a point of discontinuity. Okay. Let's look at example 3. Given f of x equals x minus 1 and g of x equals x squared, write the equation of y equals f of g of x and sketch the graph. So keep in mind when we're sketching the graph, we're going to have to consider if there's going to be any restrictions. So let's start with the original question. And let's change g of x to x squared. Okay. Now in f, anywhere that we have an x, we need to change it to an x squared. So this becomes x squared minus 1. Notice that f of x is linear. It has a domain of x as an element of the reals. G of x is quadratic. It has a domain of x as an element of the reals. When we recreated our equation, we didn't introduce any more non-permissible values. So our domain is x as an element of the reals. But sometimes the domain changes. So then when you graph it, you have to change the way you graph it. This is a parabola with a vertex at 0, 0. This is from grade 11. Okay, and it's moved down 1. It has it has x-intercepts of +1 and -1. Don't forget to label your scale. So it's going to look something like this. Just a side note, what if I ended up with an equation like this somehow, and the domain ended up being x is greater than or equal to -1? I just want to make sure you know what that would look like. Basically, I would graph it the exact same way, but if the domain has to be greater than or equal to -1, I just have to chop off all parts of the graph that don't fit with my domain. Okay? Last page for this lesson and for this unit. Example 4, again, we have f of x, which is x squared minus 1. Notice this is a parabola. Domain is x is an element of the reals. G of x is the square root of x plus 1. This is a radical function, which normally has a domain of x is greater than or equal to 0. But we've moved it backwards 1, so it's x is greater than or equal to -1. write the equation of y of g equals f of g of x, and sketch the graph. Okay, so same idea. So pause the video now and let's just focus on getting you to write the new equation and also think about the restrictions. Then we'll graph it together. So go ahead, pause the video. We'll check in a few minutes. Okay, so the first thing we're going to do is we're going to substitute g of x for x plus 1, square root of x plus 1. Then we're going to go to our f of x equation, which is x squared minus 1. And we're going to be plugging that x plus 1, square root of x plus 1 squared in there. So all we're doing is taking this and plugging it in here. The square root and the squared are going to cancel. So x plus 1 minus 1, which just equals x. So this is my equation. Now, your inner function, g of x, has a domain, which means that your solution also has a domain. So we have a restriction on the domain. So let's think about what this graph is going to look like. Y equals x is linear, okay? It has a y-intercept of 0 and a slope of 1 over 1, right? So we're going to go up 1 over 1. We're also going to go backward, down 1, backwards 1. We can keep going. But what we need to realize is we cannot keep going backwards because we're already at x equals negative 1. So we are now restricted, and that is our solution. You can see how on an assessment or in your work, it can be really easy to just draw a straight line and think y equals x. That's really easy. If you don't account for the restrictions, your graphs are going to be wrong. All right, so last example, no graphing, determine possible functions. So this is basically what we did in lesson 1, where I said if I give you what the final answer is supposed to look like, what are possible ways that you could add, subtract, multiply, or divide to get there? So f of g of x equals x minus 2 squared. We want to find out what could f of x be and what could g of x be. So the one thing I want you to think of here is that g of x is your inner function. So there's multiple ways you could do this. I'll show you some possible solutions. G of x is our inner function. So when we look at what this equals, is there a way that we can look at this and find something that could be an inner function? So we kind of want to split everything up into an inner and an outer. So for example, when I look at this, I think, well, what if x minus 2 was my inner function? So I would say, let g of x equals x minus 2. What would my outer function have to be then? So if I basically say, well, I've taken the x minus 2 out, what's left? Well, the only thing that's left would be x squared. Now, technically, the x isn't left, but I have to have an x to substitute x minus 2 in. Okay? So that's one option. In this case, it would actually also work if you made your inner function x squared, and your outer function x minus 2 squared. X minus 2. Okay? So, you can always check your work by plugging it back in and seeing how it works. All right. Any questions about that? We can go over that. There will be lots of practice questions for this as well. Let's look at this one. So sometimes it's also easier to kind of look at the whole thing as a whole. So if I think of what f of x could be, f of x could be the square root of x. What do I have to put into the square root of x? What do I have to put into it? We're going to call that g of x to get the final answer that I want. Well, if I already have square root of x, then I have to put x plus 3 into it. Okay? So that's possible functions. The last one is a little bit harder because it's not in factored form, it's not in radical form, okay? So you can always start by saying, well, if I let f of x equal exactly what it is, if I just change f of x, by adding an x, then what do I have to do to this to get to the answer? So you're basically always saying, what do I want to start off with? The outer function is what I want to start off with. What do I need to do to that outer function in order to get my final answer? So then g of x, well, what do I need to do to this? I need to divide everything by x. So g of x would have to be 1 over x. Don't forget, though, that if you introduce a denominator, you do have to account for your non-permissible values. Okay? All right, and that is our last lesson in this unit. This last part here is a little bit more complicated. It's not a very common question. You can always do some trial and error with it. You just can always check your work back in to make sure that it makes sense and that it works for you. Okay, so like for example, for the first one, I actually really do prefer the second one here, right? Where you think of the big function as x squared and you're putting in the g of x as x minus 2. That's probably the easiest way to think about it, and that's more consistent with kind of what we've been doing throughout. Start with f of x. Kind of think about what your big picture is. Is it a radical? Is it a square? Is it a quadratic? Those types of things, and then try to break it down from there. All right.